Science Geometry. Today we're going to look at lesson 11.1. We're going to start our exploration about circles. So before you watch this video, you make sure you have this note sheet in front of you. You should have gotten it right after the test on chapter 10. And if you didn't, you can print it from the link directly below this video. It's 2 pages, and all of these terms with their definitions are on it, and we're going to be drawing pictures so you get a good idea of what they are. So it should look like this: term, definition, and picture. And here's your second page. So make sure you have that in front of you before you continue on. So today, lesson 11.1, we're going to look at the parts of a circle and the lines that intersect them. So we're going to identify tangents, secants, and chords, and then we're going to use the properties of these tangents and radii to solve different problems. Okay? Make sure you got the vocab sheet. Are we ready? Now, circles are all around us. One circle is our Earth. Notice this curve, it's just part of a circle. So those circles can help us understand Earth, and you'll see them in a lot of other places also. And a circle is, definition, a set of all points on a plane equal distance from a given point, which tells us the radii are all the same. And another word for that, or phrase for that, would be locus of points. So if you hear about a locus of points somewhere, it's just a circle. So if you have a circle, whatever point in the center, we'll call it C, we can call that circle C or circle C. So instead of writing the word circle, put a big circle, put a dot in the middle of it, and then put whatever letter in the center right here. And that's how you'd write circle C. So you've got an abbreviation, just like you have an abbreviation for triangles. Parts of a circle. This is where you start filling out your sheet. A chord is a segment with the endpoints on the circle. See this segment from A to B? That's a chord. The endpoints are on the circle, and it's a segment. A secant line is a line that goes through the circle. It intersects the circle in 2 places, but it's a line. That's how it's different from the chord. They both touch the circle in 2 places, but a secant is a line, whereas a chord is just a segment. And a tangent line is a line, it's on the same plane of the circle, and it intersects in 1 point only. So that point would be called the point of tangency. So this would be a tangent line. So secant lines intersect at 2 points, tangent lines at 1 point, and a chord has 2 endpoints on the circle. And the point of tangency is where the tangent intersects. So fill out those on your worksheet, your vocab sheet. Pause the video to do it. Okay, now that you're back, I'd like you to identify, just looking at this picture, you're going to have stuff like this on your classwork. Where are the chords? Now I would look at chord, I'd look at my vocab sheet, and I'd think I need a segment with 2 endpoints on the circle. And I would say, okay, right here to here has 2 endpoints on the circle, and it's a segment. This is a line. So I would say K to M. And if you wanted to say these endpoints, J to M, the segment, you could do that. When you think about a J to M, I would think here's a line. It's got arrows. So I would call that my secant line with arrows. If you just have the part of the line, J to M, as your chord. And with a tangent line, you look and say, okay, I need 1 point on the circle. Well, this line has 1 point on the circle, point H, so that's our tangent line, line M. Okay, we can't say M to H because that's a small m, so that means the whole line. The diameter of this circle, well, you know, that's got to be a chord that goes through the center of the circle. So right here, K to M, it's a chord, but it's a special chord, it's the diameter. And then when you're looking for a radii, remember that that's half the diameter. A radius is half the diameter. So if I went, so it goes from the center to any point on the circle. So I see several. You could go from L to J. There's a radius. L to K. There's another one. And L to M. There's a third. So any segment that goes from the center to any point on the circle is a radius. And the plural for radius is radii. So all three of those are a radius. So that's how you'd identify those. Next on your vocab list, okay, two circles are congruent if they have the same radii, because that means it's the same distance from the center to a point on the circle. So, so that's all you need to know to have them congruent. Concentric are like when you throw a pebble in the water and you see all of the circles coming out, bigger and bigger. They're coplanar, so they're on a flat surface, and they have the same center. So these two would be concentric circles. You could make another one in here. You could make another one bigger. If they have the same center, they are concentric. Same radius, they are congruent. And two coplanar circles that intersect at exactly one point are called tangent circles. Just like when a circle and a line intersect, the line's a tangent line. When two circles intersect, you have tangent circles. And that can happen two ways. Notice this little circle is inside the big circle. Here's a point of tangency, so they're internally tangent because the little circle's inside the big one. And here, the circles are not inside each other, so they're externally tangent. So again, pause the video, fill in these definitions, these pictures. Then we use this. Okay, back with me, good. Find the length of the radius. Here's how we're going to use some of this. We've got a lot of information. So we want to do several things, again, like your classwork. Find the length of each radius, identify the point of tangency, that's the point where they're touching, and write the equation of the tangent line at the point. And there's two radii, so the first thing I'm going to do is come over here, and I'm going to say here's S, and we can consider each of these a length of 1, because this is 4, so you think 1, 2, 3, 4. So I know that this, if I went from here to here, I'd go 1.5 units up. So the radius for circle S, I'd say the radius for circle S equals 1.5, 1.5 units. Then if I want to find R, I'd look at this, and you can go up or over, but I would see that's 2 units long. So I'd say circle R equals 2. That's my radius. So the radius, and you know, I should probably say radii because I just put 2 in there. Oops. Then I want to find the point of tangency. Point of tangency. And I know that's the point where the circles meet. So I look, and you see it's right here. So how do you name that? Well, remember, we always put x first in an ordered pair, just like we have x first in the alphabet. So on my x-axis, this is at -2. So the x-coordinate is -2. It doesn't go up or down off the axis, so the y-coordinate is 0. Now we've got our point of tangency. Now we want to write the equation of the tangent line at that point. If you think about a tangent line, it can only touch each of these circles at the point of tangency. So it's actually going to be this x-axis. Well, whenever you've got a horizontal line, so we want the equation of the tangent line. Horizontal lines all have the same y-coordinate. So in this case, y equals, and every point on this line on the x-axis, the y-coordinate is 0. So y equals 0 is the equation of the tangent line. If it was a vertical line, if your tangent line went like this, well then these points all have the same x-coordinate. So the equation of a vertical line would be x equals, and whatever this x-coordinate was. In this case, it would be 3. So the equation of this tangent line is y equals 0. And that's not a tangent line, but it's a good reminder to you of vertical tangents. Okay? Whoop. Okay. Okay, we're out of control here. There we go. Common tangent. Again, on the vocab sheet. A common tangent is a line that's tangent to two circles, so it touches each circle in one spot. So L and M are both common tangents for circles A and B, because they touch here, here, L does, and M touches B here and A here. So they're common. Now they're outside of the space in between them, so they're external tangents. You're probably thinking, well, what's an internal tangent? Show you. Write that, or draw that picture though, please. Internal tangents, notice Q touches circle A and B, P touches circle A once and B once, but they cross. So those are internal tangents. They're inside this space between the two circles. Now, when you talk about these tangent lines, if a line is this, the other stuff, all good vocab, good to know. This is important. We will be using it. If a line's tangent to a circle, it's going to be perpendicular to a radius that goes to that point of tangency. So if I've got a point of tangency, here's my line, I draw this radius, that's a 90-degree angle. And you know we can do all kinds of things with 90-degree angles. If we know the slope of this, we take the opposite reciprocal, we'll know the slope of this. If we wanted to draw right angles in some way, we can use the Pythagorean theorem to find distances. So this is all really important. And this just goes the other way around. It says, hey, if they're perpendicular, then the line's tangent. So this is saying the same thing. This just starts with, if the line's tangent, we can say the line's perpendicular to the radius. This says the line's perpendicular to the radius, and then you know it's tangent. So to the same thing, you need it in your vocab, and let's use that. Okay? Okay, and okay, one of the things that's not listed in there, and I don't know why not, is here's a cool thing when you've got two lines that are tangent to a circle from one point, you'll know every single time. If you've got a point, you go to one tangent, then the other. These are always going to be congruent, okay? Every single time. So if you have two tangent lines from the same vertex, these lines will always be congruent. So that needs to get in your notes too. And from that, we can find HG, we can find HK, we can find A. And we're going to do that the same way we've been doing it right along. We say, okay, one more time where we've got segments that are equal. So two segments tangent to a circle from the same exterior point are congruent. That needs to get in your notes. Once you do that, you just sub in your expressions. Get all your A's on one side, all your numbers on the other. So take away 2A, opposites, add 32. Divide by your 3. We know A is 12, but don't be done there. It says find H to G. So you're going to put in 12 for A, 5 times 12, or excuse me, 4 plus 2 times 12, and we'll get 28. You could also put it in the other one. In fact, I recommend that you put it in H to K, 5 times 12, 60, minus 32, get to 28, and then you know that you did this right because the sides balance. You've done a check. So, in conclusion, make sure that entire note sheet for this lesson is complete with the pictures. And it's important that you memorize that vocabulary and those relationships because we're going to use them for the rest of the chapter. So, happy drawing and see you in class.